Okay, in this section 1.7, we're kind of setting the stage for really what the whole study of pre-calc and calculus mathematics is about. We've done a lot of things where it's just some algebra techniques that we've needed to learn, okay? And ultimately those techniques are going to help us solve real problems, because really if there were no real problems to solve, then what would be the point in even doing any math? Okay? There would probably be none. So what we're going to start looking at here is how do we use some of the mathematics that we know, okay, to solve real problems. Okay? And people that have jobs in the real world, okay, how do they use math on a daily basis to help them make predictions, solve problems, okay, develop trends, find ways to make more money, if you will. Okay, all those things are heavily involved with mathematics, and we're going to kind of start looking at that. We've looked at it a little bit in Algebra 2, a little bit in this class also, but our primary focus is going to be from here on out using these functions that we're dealing with to model data. Okay? Because ultimately, if we collect data and we can make a model for that data, we can use that model to make predictions and help us to run our business the right way or conduct a science experiment some correct way, etc. And so in this particular case, we're given a table of values here. It says this is the Consumer Price Index for housing, selected years from 1980 to 2003, based on 1983 dollars. The question is, how can we construct a function to predict the CPI for years 2004 through 2010? Okay, and as you can see, the values of the CPI are here. We have years here. And just like we've done before, we're going to go ahead and put that data into our calculator and take a look at the scatter plot of that data and see if we can identify what function might be useful here. So, with that said, I'm going to erase my list here. And I'm going to put in my years, and keeping in mind that 1980 is the starting year, we're going to call that year 0, and then year 5, 10, 15, 20, 25, and then we go up to, actually we don't want the 25, do we? 21, 22, and 23. So again, 1980 being the starting year. Our last data point is 2003, 23 years after 1980. And if I put my Y data into list 2, type that all in there, 81.1, 107.7, 128.5, 48.5, 160.4, 163.9, 169.6, 176.4, 180.3, and 184.8. And somehow I'm missing some, I missed the 98 and the 99, sorry. So it should have been 15, 18, 19, then 20, 21, 22, and 23. So once we get the data typed in as such, time as the x-coordinate, CPI in this case as the y-coordinate. And if we want to draw a graph of that and see what the scatter plot looks like, we'll go to stat plot, make sure that's turned on, and then we'll go to our window, make sure our window is good. We're going from year 0 to year 23, so I'm going to go say -5 to 30. Again, smaller than the smallest year, bigger than the biggest year. Same thing in the y direction, the smallest CPI is 81, so I'd maybe go say 70 to 184 being the biggest one, so maybe 70 to 200. I'm going to put my scale at 10 on that one because there's a lot of tick marks there if I go from 70 to 200. Okay. And from there, we should be able to see the scatter plot if we graph it. And in this particular case, if you look at the data, we might ask ourselves what kind of model might be useful here. Okay. And so we know, really we have 12 different models that we can choose from right now. We have a linear model, we have a quadratic, cubic, sine, cosine, natural log, exponential, and so on. Got a list of 12 functions that might be a good model for this. Okay, but it looks like in this case that the best one might be just a linear model, doesn't it? I mean, that data looks fairly linear, doesn't it? All right, and so get rid of my stuff in Y1. If I want to find a linear equation that would fit that data, okay, going to go ahead and do my stat, calculate, do linear regression. So I'd use a slope of 4.374, y-intercept of 83.119. So let's go ahead and type that in our y equals and see how good it looks. So 83.199. So we type in the equation that we got. And if you look at it, it fits those points pretty well, doesn't it? Okay. Just as an aside, you might have, depending on what calculator you have, if we go back to I don't have it with a TI-84. If I did this with a TI-86, however, okay, I would have that information, and I don't remember which ones have it and which ones don't. But sometimes there's an R and an R squared here when you do regression, and those values are what they call the correlation coefficient. Okay, we're not going to actually calculate that in this class. You would do that if you took a statistics class, most likely. But that correlation coefficient kind of tells you how good a model it is. Okay, and if the correlation coefficient is really close to 1, then it's a pretty good model. Okay, or really close to -1, good model. So again, as long as the absolute value is close to 1, then it's a good model. Now, if we don't have that R value, then we just have to judge by looking at it. And once again, we would judge this as pretty good. Okay. All right. Now, if this were not in a line, if it looked more like a parabola or an exponential function, then we could use this quadratic regression or exponential regression, and maybe we'd find a better one. Okay. And if you look at the different regressions you have here in your calculator, you have linear, quadratic, you have cubic and quartic, which we're going to study those two functions more in the next chapter. Okay, but we know the cubic function, that's one of our 12. The quartic means 4th degree, so x to the 4th. There's another linreg here that we did. It just essentially does the same thing. I haven't found anything that I've needed that for at this point. But the ln is the natural log regression, exponential regression, and then this power regression is something that we don't use very often either. But then logistic regression, that's the logistic function. That's one of our 12 also. So there's lots of models here that your calculator will do. Okay, it doesn't have a model for all 12, okay, but it does have a model for a fair amount of them. Okay. Questions so far?
So my graph on the proper points, but I got a different equation from yours. So when I put in your equation, it works perfectly, but mine didn't work.
Why don't you show me when we get done? Okay. Take a look. The other thing I wanted to point out here too is that, again, one of the reasons why we would create this model is like they ask us for here to make predictions for what's going to happen from 2004 to 2010. So now that we have that model in there, if we hit our table here, I have my table on auto. Okay, we already know that the model is predicting. We already have data for year 23. That's your 2003. But very easily now we can make predictions for 2004, 2005, 2006, 2007, 2008. 2009, 2010. Okay. So again, that information that we're getting from our model, okay, based on current data, it could be used to help, in this case, the government, okay, make decisions about what they want to do with interest rates, okay, what they want to do with different ideas that involve, housing and loans and so on. And so there's, all kinds of different things that they could use this data for. But this is what they do. Okay, this is why we use this information. Okay. All right. Questions so far?